Hello chemists and welcome to another episode of Bale's Chemistry. This is an introduction to covalent bonding and is AQA topic 1.3. As always, if you haven't yet subscribed, make sure you click on the link below. A covalent bond then is defined as a shared pair of electrons and both atoms in the bond donate one electron each. The positive nuclei from each of the atoms have an electrostatic attraction to the shared electrons which holds the atoms together in the bond. We can have double covalent bonds, which have two pairs of shared electrons, like an oxygen molecule, and we can have triple covalent bonds, where there are three pairs of electrons holding the atoms together, like in the carbon and nitrogen bond in cyanide. Covalent bonds can form different types of molecules. Simple covalent molecules are a set number of atoms joined together with the covalent bond, and they are comparatively small molecules, like water, methane, and chlorine. Simple covalent molecules are held together with intermolecular forces, and this means that you have strong covalent bonds inside the molecules, but very weak intermolecular forces. This gives simple covalent molecules a low melting and boiling point, and this is because those intermolecular forces are easily broken. They also make good electrical insulators. The other type of molecule that we're going to look at is giant covalent or macromolecular. Macro means large in scale, where molecule is a group of atoms bonded together. Two macromolecular structures that we're interested at is diamond and graphite. Graphite has a macromolecular crystal structure. It's soft as it forms layers that are held together with weak intermolecular forces. It conducts electricity because it has a delocalized electron. It has a low density because of the space between the layers. It has a high melting point due to those many strong covalent bonds, and it's insoluble in water or organic solvents. Looking at diamond then, diamond also has a macromolecular crystal structure. It's different to graphite as it doesn't conduct electricity as it has no free electrons. It's very hard as each carbon atom is covalently bonded to four more. It sublimes at 4000 degrees Celsius. Sublimes means it turns from a solid straight into being a gas. And it's also insoluble in water and organic solvents. A slightly different type of covalent bond is a coordinate bond or dative bond. This is where one atom donates both electrons required for the covalent bond. We can represent this bond as an arrow showing the direction of donation. There are three examples of molecules with coordinate bonds that have made an appearance in recent AQA exam papers, and it's important that you can recognise these. So to summarise this episode then, covalent bonds are shared pairs of electrons. Simple covalent molecules have strong covalent bonds but weak intermolecular forces. Giant covalent molecules have lots of strong covalent bonds. And a coordinate bond is where one atom donates both electrons required to form that covalent bond. Thanks chemists for watching this episode of Bale's Chemistry. There are more bonding videos if you click up here. And if you're not already, make sure you click below to subscribe to the channel.